Welcome to quiet earth time. Take a slow breath in and let it fall away gently. Allow your shoulders to soften, your jaw to unclench, and your thoughts to drift like clouds over water. Today, we will explore a question that has quietly crossed many human minds, perhaps while standing at the shore, tasting salt on the breeze, or watching waves roll in and out with a patient and methodical rhythm. Why is the ocean salty? The answer is not sudden or dramatic, nor is it a single event or a single place. It is a story that unfolds over immense spans of time, shaped by rain, stone, rivers, heat, and gravity. Like the ocean itself, it is deep, gradual, and continuous. Long before there were people to wonder about it, rain was already falling on the young, new earth. As raindrops touched bare rock, they began a subtle process of change. Water is gentle, but it is persistent. Over thousands and then millions of years, rainwater slowly dissolved tiny amounts of minerals from the land. These minerals included elements like sodium, calcium, potassium, and chloride, substances that, in different combinations, formed the salts we recognize today. Each raindrop that fell on mountains, hills, and plains carried away an almost unimaginable small trace of these dissolved minerals. Alone, a single drop changed nothing. But there have been countless drops, falling day after day for billions of years. Water gathered into trickles, trickles into streams, streams into rivers, and rivers, patient travelers of the landscape, carried those dissolved minerals downhill. Eventually, nearly all rivers lead to the sea. When river waters enter the ocean, it brings with it everything it has collected along the way. Sediments, nutrients, and dissolved salts. The water itself may evaporate back into the sky under the warmth of the sun, but the minerals do not evaporate. They remain behind, suspended in the vast body of the ocean. Imagine filling a bowl with water and a pinch of salt, then allowing only the water to leave while the salt stays behind. Repeating this process again and again would slowly increase the saltiness of what remains. This is, in essence, what has happened to the oceans, not over days or years, but over geological ages so long that human history seems like a blink in comparison. The sun warms the ocean's surface, and water rises invisibly into the air as vapor. This vapor forms clouds, travels across continents, and eventually falls again as rain or snow. When it falls on land, the cycle begins anew, dissolving minerals, feeding rivers, returning to the sea. The ocean loses water but keeps the salt. Over immense spans of time, this quiet accumulation has made the ocean distinctly saline. Not all salts in the ocean come from the land, however. The sea floor itself is alive with geological activity. Along underwater mountain ranges known as mid-ocean ridges, seawater seeps down into cracks in the Earth's crust. There, it is heated by magma far below the surface and reacts with the surrounding rock. This heated water then rises back into the ocean through hydrothermal vents, carrying dissolved materials with it. These vents are like hidden underwater springs, continuously exchanging substances between the planet's interior and the sea. In some places, they release water so hot it would boil at the surface. Yet, in the deep ocean, it flows quietly into the surrounding cold darkness, rich with metals and salts. At the same time, other processes remove certain minerals from seawater. Marine organisms build shells and skeletons from calcium and carbonate, eventually settling to the seafloor when they die. Chemical reactions form new minerals that become a part of ocean sediments. In this way, the ocean is not simply accumulating salt without limit. It is maintaining a kind of long-term balance, a steady composition shaped by many inputs and outputs. Still, sodium and chloride, the components of common salt, remain abundant. They are highly soluble and less easily removed than many other substances. Over time, they have come to dominate the chemistry of seawater, giving the ocean its familiar taste. If you were to evaporate a large quantity of seawater completely, what remained would be a crust of salt and other minerals, a quiet record of the ocean's history written in crystals. Yet, despite this salinity, the ocean does not feel harsh or concentrated in the way a brine solution might. Its vastness dilutes everything. For every liter of seawater, only a small portion is salt. The rest is still water, water that flows, circulates, absorbs heat, and supports an astonishing diversity of life. Salt itself plays an important role in the ocean's behavior. It affects how dense the water is, how it sinks or rises, and how currents move across the globe. Differences in temperature and salinity drive deep circulation patterns, sometimes described as the ocean's slow heartbeat. Currents that take centuries to complete their journeys from one basin to another. These currents transport warmth, nutrients, and oxygen, influencing climate and ecosystems far from their origin. In this way, the saltiness of the ocean is not just a chemical curiosity. It is part of the system that makes Earth habitable. If you stand at the edge of the sea and taste the air, you may sense salt carried in fine spray. That salt once lay hidden in rock, traveled through rivers, circulated through ocean depths, and was lifted again by waves and wind. It has been part of storms, ice, tropical waters, and polar seas. It may have passed through living organisms and returned again to the water. Nothing about this process is hurried. It unfolds at a pace almost beyond human imagination. The ocean's saltiness is, in a sense, a memory. A record of rain falling on ancient mountains, of rivers carving valleys, of continents shifting, of volcanoes shaping the sea floor. It is the quiet accumulation of countless small changes, layered over time until they become something vast and enduring. As you rest now, imagine the surface of the ocean at night, dark and gently moving under a sky full of stars. Beneath that surface lies water that has traveled the planet again and again, carrying dissolved traces of land and life, warmed by sunlight, cooled by polar winds, stirred by tides that have risen and fallen since long before human eyes ever watched them. The salt in the ocean is not separate from the earth. It is part of the ongoing conversation between rock, water, air, and time. And like the tide, that conversation continues, steady and unbroken, whether we are listening or not. Thank you for drifting through this quiet exploration with me. May the steady rhythm of the sea bring you calm, perspective, and a gentle sense of connection to the ancient processes that shape our world.